Looks like we have a few folks joining in.
Awesome.
Sweet.
I don't know if they can chat, but
Cool. Hello, everyone, and welcome to the HackFS 2024 Lilypad workshop titled Universal Basic Compute for Actually Open AI. Joining us today is Ali and Steve, who will be taking us through the session. And with that, I'll pass it over to Ali to get the session started.
yeah, hello. Thank you, Calvin, and thank you for hosting us again, Eve Global. I feel like we just saw you in Sydney, but we're back for HackFS. I'm really happy to be back again for this year's HackFS because it's actually Lilypad's 1 year birthday kind of this week. And we've come a long way since we launched Lilypad V0 at HackFS last year, really, as a bridge between FVM smart contracts and a backyard peer-to-peer compute instance. So there's so many things we've accomplished since then, and I'm excited to share them all with you here today as well. So for those who don't know you, I'm Ali. I'm the founder and CEO of Lilypad, and I'm joined by my colleague Steve here, who's going to run through how you can use the Lilypad network for AI, ML, and other embarrassingly parallel compute jobs today. So firstly, a little bit of background. So open data and infrastructure, they're not just interesting and topical fields of study and growth, but to me, how we build or don't build these pieces of technology is really going to be absolutely essential to ensuring that we provide equitable access to technology and the web and to AI in future years. And it's kind of a major driver behind the Lilypad project. What does open infrastructure stack look like, though? And what components do we need to build one? So if we think about it, the modern web stack is really all about data, which is what we love here at HackFS as well. It's made of three components: networking, storage, and compute. These components pretty much form the basis of everything we do in today's connected web era. So, however, in the decentralized story, compute's kind of been a bit of a missing piece of the decentralized infrastructure story, with some experimental exceptions. And this is for probably a couple of reasons. Firstly, there's a lot of complexities involved in building a fully distributed compute network. And these are like, the research is still ongoing into a lot of this as well. And secondly, as a space, we probably just weren't quite ready. There was more pressing problems to solve, like internet scale storage or block scaling solutions and L2s, or account abstraction even, which I noticed Vitalik's thrown a spatter into recently as well. Either way, and also I think the demand perhaps wasn't just there. Speaking of demand, this has never been kind of more of a relevant problem than it is now, with the explosion of AI and ML driving this exponential demand for compute and compute resources. So this isn't just demand for training large foundational models like ChatGPT either, but which are currently really only the domain of like large companies that are able to access vast amounts of data and compute power. But the demand for AI compute also includes running models, so running inference models like stable diffusion text to image or LLM prompts, or fine-tuning models via low-rank adaptation, for example, or other merging algorithms. So compute is kind of a basis for both of these things. And this is kind of why we think this is a future. We're hoping Lilypad Network can play a big part in helping to create this kind of now frontier of open infrastructure, as I'm calling it, in the distributed compute infrastructure. So what is Lilypad? We're a flexible, global, and permissionless distributed compute network. We enable internet scale computing jobs, including those AI and ML workloads, while also unlocking idle processing power and new market opportunities for participants. And we're also hoping that this means that it opens up a new data economy, especially combined with some of the other projects that are building in the Filecoin ecosystem or the data ecosystem as well. So in practice, this means we're building a marketplace for compute jobs, aiming to be able to provide more accessible and cost-effective computing power to consumers via an independent kind of global marketplaces that uses this distributed hardware network with inbuilt trust mechanisms. And you don't need to be a data center to contribute. or no, be an AI PhD to use it. So if you want to run a text-to-image model, then you could do that on our network of hardware, or alternatively, if you have spare compute around, perhaps you have a really high-spec gaming computer, you could put it to use and be rewarded for running verified workloads for other people on the network. So it's you shouldn't need a degree in AI to access this or to run your GPU on it either. Let's dig into how it works though. So firstly, we are live and running, or, be pretty weird to be at a hack if you couldn't build anything on us, but we are live and running. We have a testnet version. It's called the Milky Way testnet. We're fully EVM compatible. So under the hood, Lilypad combines off-chain compute implementation details, which are derived from Bacria, the peer-to-peer compute project we first started off out of. And it provides on-chain coordination, incentives, and verification. And we do that with our ERC20 token to pay for jobs on the network. It's built in Go and Solidity, and the current testnet is on a local GethNet, but we're going to be building this out into multiple different chains. So we're fully EVM compatible, and we'll be launching on several of them in future. So in terms of how we make sure that people do the right thing and run the jobs as they say they're going to, we use optimistic reproducibility with collateral staking to incentivize those good actors and discourage cheating and collusion in the network. So this kind of provides for the optimal performance in the network while still providing trust. And this is Juan's distributed compute triangle. Basically, if you've heard him talk about this before, Juan Benet, the founder of Protocol Labs, if you've heard him talk about this before, he says privacy, verifiability, and performance are all part of the big pieces of a distributed compute network. Choose to. So we went with verifiability and performance, and we have research into privacy, including T and non-determinism underway at the moment as well. All right, how do you run compute jobs on Lilypad? Well, to enable the kind of verification that we use on the network, all compute jobs have to be deterministic. So to achieve this while maintaining the flexibility to create and run your own jobs on the network, we employ what we're calling a module system. A module is just the specification for a compute job to run on Lilypad, combined with like a containerized script, like a Docker container or arbitrary WASM script. And that's all it is that we call a module. So basically you can get a Python script from Hugging Face, make sure it's deterministic, and that's not too hard to do with a lot of AI jobs, by the way. But you can make this deterministic, put it in a Docker container, and then add a simple Lilypad spec, and you'll be able to run this module on Lilypad. And Steve is actually going to run through how you do that in practice a little later in the project here, a little later in the agenda here. So what's really great about this module system, though, is that it provides flexibility to users to kind of define their own parameters for running compute jobs and what the job should look like. And it also has this like really big advantage of being able to enable a module marketplace. So we can have the community help us build out what they want to see and run. And creators can even charge a small fee to other users of their modules. So this kind of bootstraps the ecosystem a little bit as well, and also leads the way for further plugins to be built out to really create more of a decentralized AI ecosystem as well. So there's currently several modules. What can you do with it now without having to build your own? There's currently several modules already available for use, including, of course, text to image with Stable Diffusion. There's a text to video module, which is pretty cool. Text to speak and speech. Sorry, if I can speak, I'll tell you what that module is. No. And coming this week, we're also adding Llama 3, which is the Meta AI's LLM module, and potentially even fine tuning. And for the DeSci enthusiasts out there, we're actually also adding the AlphaFold 2 module. So we'll be running through a few of how to use some of these modules as well now. So there's multiple ways to use Lilypad as well right now. So the first and easiest way is to use CLI. You can also trigger Lilypad jobs from a smart contract, and we've actually built out a hard hat template you can use. If you want to do that, it should be up and running by the time you start hacking tomorrow. And there in future, we'll also be adding APIs and SDKs to this. But currently, we also do have a JavaScript wrapper for the CLI, so you can run this in your front ends as well as a whole tutorial on how to do that too. So some great ways to use and run Lilypad in your hack projects. Hopefully, it kind of covers a lot of them as well. Enough rambling. Let's get on with how we use it though. Basically, like any other project, we have a testnet. We are using a token, so you need to get on, add us to MetaMask, basically right here. This is all in the docs as well. Add our network to MetaMask and get some testnet tokens from our faucet. You should be able to do that fairly easily, much like any other project. Then you're easily able to install Lilypad, which is basically just a couple of lines of code on your CLI. If you're installing it another way, for example, with an EVM or, with your smart contracts, then please go and read our docs for how to do that. But if you're using the CLI, it's just a couple of lines of code to install Lilypad here, and you can do it with either I think you can either do it with the Go binaries or you can use the bash commands to do that. Couple of lines of code and you're up and running and can you run Lilypad jobs, which is pretty exciting. I didn't realize this one was here. Here we go. So this is, we're just talking about our Node CLI wrapper here, which we've just made as well. If you do want to use the JavaScript wrapper for your jobs, you can go to this quick link, lilypad.team/JS CLI, and that will take you straight to the JavaScript CLI wrapper as well. So you can use that from your front end projects. Check out the docs too. There's also a whole tutorial on how you would use that. Let's see one of the modules actually running in the CLI though, hey? Steve, did you want to maybe take over here actually?
Yes, let me just work out which slide you're on, just so I can sync it up. But yeah, if
27.
Right, almost got it. Amazing, thank you. Yeah, I've got a few. Let me do a screen sharing thing, and ta-da! There we go. So this is for a new one of our new modules, which is one of our it's a demo module. So essentially the hello world of compute. This module basically, or this containerized module, basically runs the classic Calce, but with a Lilypadian twist to it. So this one will actually, that's what it looks like when you're running, and that's the prompt to run it on. As Ali was saying, that's once you've got the CLI installed, which is really super quick and easy to do. Once you run that, you'll see that kind of screen start to appear to signify it's running, and you'll get something like that without the rickroll. You'll get that wonderful little ASCII art output. And of course, this is just a hello world, so this just gets you up and running. There's a few variations you can run with that as well, just to flip over to that. This is currently on our GitHub, as you can see, so you can check out how we built that if you wanted to build your own. And this also includes a nice write-up on how to use the Go template, which we have a boilerplate for as well on our GitHub as well. But I'll get to that more in a moment. As you can see here, I've also included a bunch of prompts so you can change the ASCII art image just from your command line, which is pretty cool. But let's have a look at, but wait, there's more. Let's have a look at some others. We also have the SDXL pipeline, which similar to the Hello World, the Calce, you can run from the command line with a couple of prompts and get some really nice imagery out. You can get really fancy with this one too. This one has a whole bunch of prompts, and I don't have the GitHub open, but there is on the GitHub write-up for this particular module, you can start to add some extra prompts and do things like seed changes, so you get a different image out, and you can also increase the number of steps that the image will go through being iterated on to make it look better and add more detail and just overall a nicer image. And that will, of course, basically dump you out a much nicer image. To show you what that looks like, let's switch over to this one. And so this is one of my prompts here. Once I run that, and in the interest of time, because we haven't got too long, here's one I prepared. Oops, that was actually supposed to do that. So once you run that job and you get that completion come back and the results come back in, you'll get a folder which looks something like this, and that will produce, open a window, that will produce your image. That's where your image output appears. And the one we're about, while I'm here, is another one I prepared earlier. One of the other ones, I'll flick back and show you in a sec. This is for the video. What video won't go? There we go. I'll switch back to the slides in a second and show you the prompt for that. There we go. So that's the SDV video module, which you can produce. And I'll switch back to my slides. There we go. There we go. So that's the prompt you can do, and there's a lot more inputs you can add to that to make the video run smoother, run a different frame rate, and include more detail as well. And it's literally just a time-based sort of processing time. The more prompts you add in, the more detail you want to get into that particular video as well. But that's the video you can get out of it, and you get 3 different formats from that as well, which is pretty fun. Not going to run through some of the demos on these, but they're all on our GitHub, and we've got all the write-ups in our docs as well. But as Ali was saying, we do have text-to-speech module, an Olama, which is just about to be released, so stay tuned for that. Actually, join our Discord, because yeah, we do tend to drop a lot of new stuff into that as well. So drop in there. As Ali said too, AlphaFold 2 is coming, which is cool for those that want to do a whole bunch of fun DeSci stuff and protein folding. Which is always fun. And smart contract, which we should have out in the next few hours. So you'll be able to do some smart contract stuff for too. And if you're looking to, if you've got something like a containerized idea or an app that you need help with, please reach out to us either on the Discord or through any of our social channels, because we'd love to chat more about that. This JavaScript wrapper is super new. We are just about to release this for you, so it will make it nicer to build into any sort of app you're looking to build out, because this basically will let you build it into like Express app or some type of JavaScript, either browser side or client side, or sorry, server side. That's not the right code. That's the code. So this is the super new wrapper. What it does, there's 2 parts to this one. You can set up, actually there's a few different ways you can use this, but the way I'm going to show you how to use it, you run the node index, you run the index from the wrapper as an endpoint, which is all I'm doing here for testing. And then you can throw a post request at it. So I'm going to use a little curl here to do that. And it will basically run any module that I've just shown you and return you just the key you need to be able to access where that particular output comes from. So here I'm running the module, and you can see from the curl, I'm running the Lilypad module, which is this here. And then I'm including the input message test, which is the input that the module is going to need to output the ASCII art with that module. Oh, there we go, and it's done. And as you can see, the response I've gotten back is just some JSON with the relevant keys I need to be able to access that output. So if I grab, I'm going to cheat a little bit here. If I grab that output on the server side, and then I can do a cat on the result, that's the module that I just ran, and I was able to get that back programmatically. So you can build that into, well, anything you want really. If you're doing like some type of NFT thing, you can get an image generated, get it once it comes back, and you can handle and process it as you need to throughout your own system. So, oops, probably need to switch to my slides before I start switching slides around. If you want to run distributed networks, so if you have GPU and you want to contribute to the network, not going to show you how to do that in this session, but please reach out because we'd love to chat, and we cover how to do that in all our documentation as well. But if you want to run build your own module, we definitely want to talk, because that's where we're having a lot of fun at the moment, building things out like Olama and the protein folding module, which is super cool. And as Ali said during the technical part or the technical deep dive, is job module is literally just a containerized app. So think of the likes of Docker, where you can take a nice script, have an entry point, and build a bit of a Docker file around it. You can do the same thing with a Lilypad template file, which is really, really easy. There are a few rules and caveats to that though. Currently, you have to ensure that the module adheres to determinism. So you have to make sure that the output of the module is reproducible, so that our mediator node is able to validate that the job worked as intended. The other thing to keep in mind is strip out any sort of unknown outputs like timestamps or any type of logging that you may not want to appear in your results, because it may actually appear in your results, or throw everything out completely, which you don't want. And then just avoid reading from sources of entropy such as dev random, et cetera, et cetera. The spec itself, I'm not going to go through this in great detail, but as luck would have it, I literally just published a blog post today or tomorrow, depending where you are in the world, which is available on that short link there. And it goes through all the nuances to the template. It's essentially a Go template, spoilers. It's essentially a Golang template, and it's pretty easy to set up once you've got everything containerized, and you literally just have to point it, host it in a repo so that it's publicly available, and you can call it from that command line, like I was showing you on the demos, and reference a publicly available image, which you can see kind of in there. But again, we've got write-ups in this in our GitHub, on our docs, and on our blog as well. We've got a working example of everything you're going to need to know. And again, if you get stuck, reach out. I'd love to chat. The only other thing to keep in mind then is if you're building an image, if you're building a custom image and you're pushing it up to, say, Docker Hub, for example, which is what I did with the LilySay example, then you just have to tag it as with some type of number or identifier, so you can reference that within your template code. And then from there, it's literally just a Lilypad run from command line, or doing a JavaScript wrapper call, referencing your GitHub where your Lilypad template is, and then that'll just pull the image in and run the job on network, which is pretty easy, which is what I did for the LilySay as well. And you get those wonderful results, well, videos or protein folds or whatever it is that you're out to do. So, and with that, I'll pass back to Ali.
Thank you, Steve. Super awesome. Alrighty, let me again share the slides. I love the memes scattered all through our presentation deck now as well. Myself and Steve have been working together for a while, so we sometimes have a similar style come through too, but it's good to see. Anyway, we're here for the real stuff, right? You want to contribute to Lilypad, you want to win hackathons. So I think like one of the things to think about when you are building your hackathon project, or you want to use Lilypad in your hackathon project, it's just a vision, or what crypto can do for AI, or what AI can do for crypto as well. And I think there is this really great intersection where crypto is and blockchains are solving some of AI, the emerging problems that AI is bringing up, things like proof of humanity, data provenance. There's kind of like this whole suite, or this whole new field that is popping up, especially in the blockchain space, or at least that's and especially in this kind of data space that we're playing in within blockchain as well, that we're uniquely positioned to solve. So have a think about some of the ways that crypto and AI can play together, and how crypto could solve some of AI's problems, or vice versa, when you do think about it. And I really love this quote. It's on an A16Z podcast episode as well, which is it came out last year now, but I think is still super relevant to like giving a good landscape overview of the space. So have a listen to that if you're interested as well. It's just called Crypto Across AI, I think, the podcast. All right, we've also gone to the effort of writing up a whole page in our docs of things that you could do to help contribute to Lilypad or ways you could win hacks. So we go through a bunch of things in here. There's a lot of DX improvements because basically Lilypad is in beta. We would love to see some developer experience improvements here if that's the sort of thing you like to build. That'd be awesome. Things like chaining or batching job scripts, that would be cool. Things like making the module making experience easier for other folks, definitely going to be useful. Or integrating a crossover POCs as well. So this is a hackathon, so I know you're looking at the bounties and going, oh, there's so many great projects here that I want to try out. Maybe there's definitely a lot of potential with Lilypad to do a crossover project. So integrating with storage, integrating with, I know ChainSafe has a Unity SDK they're looking to have extended. It'd be really cool to be able to use Lilypad within Unity. And I think it's probably not super hard a lift to try that one out, just hinting there. That would be really cool to see applications of Lilypad in gaming. There's a whole heap of other, I really like the graph as well. Integrating with the graph would be super cool here. And there's a whole heap of other, like WeatherXM. I know they're here and we were talking to them about doing a POC. So there's definitely a lot of options for you to kind of collaborate with other teams that are also part of this hackathon and sponsoring this hackathon too. The other thing is just end user apps. We'd love to see what you want to do with this across like all of the blockchain verticals as well. Like there's DeFi jobs, there's decentralized science jobs, of course, AI and ML in crypto, like I was talking about before, things like the waterlily.ai app. Check out that use case in our docs if you want to learn more. And we also actually have a, if you do need more inspiration, we have a project showcase in our docs as well that you could have a look through at past winners, including some of the original past winners from HackFS 2023. So I'm so excited to see what people build over the next few weeks here as well. If you do want to get involved, please you can take a look at this QR code. It'll take you straight to our link tree and you can get in touch with us that way. Also, what's next for Lilypad? So as I mentioned, we kind of launched Lilypad a year and a bit ago. And one of the first talks I did on it was at HackFS last year. We've now raised and we have a full team and we're working towards launching our mainnet towards the end of the year. So you can check all this out on our docs and blog as well. Otherwise, I am happy to take questions from anyone here. Thank you for all joining us, hacking on us, and being here with us. Thanks, ETH Global, as well, for having us on again. Calvin's back. Happy to take questions.
Cool. Thank you so much, Ali and Steve, for joining us today and for the great presentation. But
welcome.
if there are any questions, feel free to unmute yourself and shoot your questions. I think Ali and Steven would be more than happy to answer them.
Absolutely. We're right on time too. I thought we were going to go way over time, but we nailed it.
Yeah, absolutely.
Awesome. If you have questions later as well, feel free to shoot them to us in the ETH Global Hack channel. We're happy to answer those. We're also going to be hosting office hours for the hackers over the next couple of weeks. So stay tuned in our ETH Global channel for times for those. Yeah, we're around to help though. Let us know if you need anything.
Great. I think we have more 2 minutes, so maybe we can wait for anyone if they want to unmute themselves. Feel free to drop down your questions on the chat box. I can pick them up or Ali can pick them up.
Yeah, absolutely. Happy to riff on some other things too. Oh yeah, so we've actually implemented the smart. I was talking about the smart contract one. So we're just about finishing up a hard hat template that people will be able to just kind of deploy and use within GitHub. So it works on just a GitHub VS Code instance, and that leads directly from our GitHub. So if you want to play around with it from smart contracts, there should be an example up and running by the end of tomorrow as well. And then, yeah, like we said as well, I think in this we'll have an LLM module ready to go in the next day or two as well. So lots of options for integrating kind of a large language model or text to image, text to video into kind of end user apps as well. But I mean, we got a couple of really great hackathon entries at Sydney as well. I mean, one of them, Steve, did you want to talk about the winner of the ETH Global Sydney hackathon?
I do, and actually, it helped inspire not only inspire our JavaScript wrapper that we released for this one, but wait, can you hear me? Yes, can you hear me? Not only helped inspire that, but a couple other enhancements as well. But essentially, what it does is run a city grid scenario or city grid output using Lilypad, all built into a container. It is literally like 30 lines of Python that you can dynamically change from an input, and yeah, it helps with a city mapping grid for a NFT game.
Yeah, it was basically like kind of an autonomous agent with its own brain that was Lilypad job, right?
Yeah, yeah.
It was very cool, definitely. What was the name of that? I've forgotten the name of because you can look up the code on ETH Global.
Learner, Leanr.
That's right. That's right. Yep. I think it's in our docs as well, but otherwise it's definitely on the ETH Global showcase. That was kind of really cool. And the other cool one we got was the CI/CD to a cache network. So actually spinning up in a cache node to run Lilypad on, which was really cool, actually. They put a lot of effort into that too. That was just in a weekend. I can't wait to see what we get in like 3 weeks to 4 weeks here. All right. Probably.
All right. So thank you everyone for joining. Feel free to connect with Ali and Steve in the partner channel on Discord if you have any questions or if you want to take up any conversation ahead, not just now or anytime during the period of the hackathon. So thanks, Ali and Steven again. See you all. Cheers.
Thank you. Talk soon.